Hello everyone, welcome back to the workshop. I've got a D7 video for you. We are looking at the crankshaft. Now I know what you're thinking, the engine's back in the frame. How can you be looking at the crankshaft? Well, I wasn't happy with it, quite frankly. I took it out for a couple of test rides with the old saddle tie wrapped on, basically, well, bungee strapped on, and the bike was vibrating. I wasn't happy with it. I was pretty sure it wasn't meant to be like that. So before I could change my mind, I decided to pull the engine and take the crank out and have another look at it. Lo and behold, the mag side shaft was showing a bit too much deflection. They do get bent because they're quite spindly. So that was something that I'd overlooked. So got a new mag side shaft, and this video is about fitting that, getting it into the crank and getting it back together. It was going to be a much longer video. Unfortunately, I've lost quite a bit of footage. The tripod went over with my Android phone on it, which is what I do all my videoing on, and yeah, it was all over the floor. So I've got a new Android phone which we're talking to you now on, and it's just me. Anyway, I'm talking to you now on, so we'll see how that goes. So some of the footage is on the old phone, some of it on the new. The great news is that Bones was here last month. Bones from BSA Bantams in Australia. He was in the UK, he'd been to the Manx Grand Prix, and he called in here and for an overnight stop, which was fantastic. We had a few beers and chatted about everything really. We put the world to rights. But I've got some footage of his visit to the workshop, and thankfully I've managed to recover that, so you'll get to see that. Right, let's get on with the video. Welcome back to Retro Mechanica. Look who's here, special visitor all the way from Australia. It's only Bones from BSA Bantams.
How are you all? Yeah, Dean and I have had a couple, and we are having a really good old chat here in this wonderful workshop. Great machines, great machinery. The Bantam's looking fantastic. Yeah, we've had a really good chat. So obviously Dean's got an engine pulled down on the bench here, a couple of little minor issues, but he'll have that back together in no time. So yeah, really good, and great to be on the channel. I watch it all the time. That's how Dean and I sort of, well, met in a way. So communicating through the internet and all that, and on YouTube, doing our respective well, channels, I suppose. So if you haven't watched any of my stuff, go and have a look at BSA Bantams. You're going to get a plug in here, mate. BSA Bantams or Tony Farmer. So if you're interested in any Bantam stuff and engineering stuff, we both do very similar stuff, don't we?
We're the Bantam guys, we certainly do, yeah. And all I can say is, if you're not watching BSA Bantams, Tony Farmer, you absolutely should be, and it's a real pleasure to have the legend that is Bones here in the workshop. So thanks for watching.
Thank you. See ya.
Okay, we are set up in the press, and those of you that have been watching my videos for a while might think, hang on, he's moved the press, and I have. It's on the other side of the workshop now. I've had a bit of a cabinet reshuffle. We're going to see how it works over this side, just to give me a little bit more room for my toolbox on the other side. These 12-ton presses are fairly universal. You can get them in most markets, and very useful and affordable too. So most home workshops, if you've got the space, you can have one. There's a few modifications I'd like to do. The fit of the beam, the jacking beam in the frame isn't great, and a lot of people put sheet metal slips in between to give a bit more accuracy, or less movement, and I think that's something that I'll do. I'd also like to change the jack for a pneumatically operated one, so that I can just stand back and press a valve and off it will go. I think that's a worthwhile upgrade. And also here, where the jack ram bears against whatever it is that you're pressing, it's not a particularly well finished piece of kit, so I think I'd like to remove this and put something a bit, a bit more well finished, with a fitting on the end to interchange mandrels, which I'll make up a mandrel each time, and then I'll end up with a full set of mandrels that fit into the jack ram and do all the jobs that I'm likely to do. At the moment I'm just using this piece of aluminium, which is what I used last time. It's got a little pip turned on the end so that it fits inside the drilling in the crank pin for a more positive location, and I've just wound some tape on here just in case anything moves. Hopefully the tape will prevent it from turning into a high velocity, low caliber projectile, but we'll see. It hasn't happened yet, but it could. I've got my homemade crank splitting tool here set up, ready to push the pin out, and I've just put some strips of sheet aluminium underneath I will try to catch the crank, but just to try and help it from tumbling through the gap. So we're ready to go, I think. I'm just going to open the workshop door because I want to stand that side of the handle, so right of where we're standing now, and then we'll do it. And no doubt the pop of the crank pin will make us jump like it always does, even though we're expecting it. So let me just get the door open. Okay. Oh, it started raining. Perfect. Let's give it some, give it the beans and see what happens. I say this 12-ton press had the minerals last time, so there shouldn't be any reason why it hasn't got it now. Oh, there we go. Okay, first stage done. Let me just swap everything round and we'll press the pin out of the other side. Right, here we go again. We're just going to press the other half, the pin out of the other half of the crank. Oh, there we go. Okay, liberated. Right, we'll go back over to the workbench. Right, back at the bench, and I've got the surface plate and the height gauge out. So we're going to measure off this height here, and I think we'll take a reading for the bearing portion here as well, just to make sure that when we put it back together with the new shaft, we get everything in the right place. We will compare the old and new shafts once this is out, and then obviously if there's any discrepancies we can compensate by how far we push it through, but hopefully they'll be the same. This is flush on the back, so that's what the service sheet is saying it should be for this year. As I say, if they're both exactly the same, then we'll just put it back to standard. Everything's been cleaned. Back of the flywheel has been deburred, just to make sure that it sits down nice and flat, and yeah, let's take a reading. So I don't know if you'll see the display on the height gauge. I've got you zoomed in a little bit, but I don't think you'll be able to read it, but I'll tell you what the numbers are. So that's zeroed off on the table, and we'll just come in. Make sure we're settled. That's 126.12. I'm working in millimeters again. So that's reading 1. Let's take a couple more. Go back to 0. Yep, zeroed out. Same again, 1, 2, 6, 1, 2, and I'll just do it again. Zeroed out. On the money. Right. I'll just take one measurement of the bearing on camera because it's not the most exciting thing in the world, is it? Watching me do this. .17. Right, I'll get the rest of those and then we'll go over to the press, push this. Okay, that's smoky hot. Let's give it the beans and see what happens. Wow, that was a good one, wasn't it? I don't think we could have got that if we hadn't warmed it up. Right, I just need to get a glove because I don't want to catch that thing out the bottom with my bare hands. That would be a bit of a day out, I think. The next thing is, am I going to have enough on this mandrel to get it all the way out? And the answer to that question is no. Let's just get something to interpose in there. 1 second. Tell you what, while I'm rooting around, I'll just switch you off so you're not waiting. Well, you didn't miss much. As soon as I put weight on it again, it fell out. I just used a little narrow socket and out it came. So there we go. Wow, that's hot. I can feel it through the gloves. I'm going to let that thing cool down, and then we'll get it over to the bench and do some comparisons with the new one. Okay, everything's nice and cool now, so I'm just going to do some comparison work. So I'm just going to check out the overall height, the height where the threads end or begin, depending on which way around you're looking, and the height here where the taper begins. And that'll do. That's all the measurements I need because they're the features that matter the most on my installation. But you could measure every feature if you wanted to. But I'm just going to do everything on this shaft and then compare it with the other one. And as long as it's near enough and close enough for government work, we'll be fine. We'll just know how far to push the shaft through the flywheel. So let's do that. Got it zeroed out on the bed there, on the surface plate. Just make sure that that's pulled into the V block. 122.37. Just yeah, 122.38. So 122.4. We'll call that. Okay. Let that settle. 97.15. And as I say, I'm just doing this sort of quick and ready, whatever you want to call it, just to give us an idea. Just do that one again, didn't feel quite right. I'll just make sure I was zeroed. feel like I might have pressed a button there by mistake. $52.47. Okay. I'll just swap out the new one. Where's it gone? Oh, there it is. You notice that I've marked a line on it. If it's coming up on the camera, that's just the centre line of the keyway. And good enough for what we need it to be. Right, so overall height, let's make sure, let's give that a quick wipe. Make sure it's pulled into the V block. $124. So it's got about 2 mil. Which isn't a problem, because we don't use that portion of the shaft with the CDI system, and even if we did, it would just protrude through the bush in the stator plate. 99.8. So about 0.9 of a millimetre, just under. Again, I think we can live with that. And then this is the important one, I think, really. $50. Just make sure that's right. Yep, we zeroed out. $54.4. So again, about a mil. So I'm happy with that. We will put this in exactly how the other one was fitted, with the plain end flush with the inside of the flywheel. So we need to get it started, I think. Okay, almost ready for our new main shaft to go into our flywheel. And I've got the new main shaft in the freezer at the moment. I've marked the centre line for the keyway, and I've also marked a line for the depth. And what I mean by the depth, let me just show you the service sheet. There we go. You can see our angular dimension there, 17.5 degrees. And you can also see, let me get that one more central, that on some cranks, the main shaft doesn't go all the way through. Depending on what year and what crank you're working on, if it's a narrow big end or a wide big end, it depends on how far through you push the main shaft. We're going to push ours through until it's flush with the recess on the back, not flush with the outer dimension, but with the big end recess, because ours is a wide big end crank. And we will be going from this side. I've got the old shaft here, let me show you. We're going from this side because there's a nice lead-in taper, and obviously we only want to push it the shortest distance possible. So we're going to push it on this end. If we did that, we'd probably end up bending the shaft. So I've made a little push tool that bears against this face here. So that way we're at the sort of shortest and stiffest part of the pin, and we've got no danger of bending the smaller dimensions, the smaller diameters out here. So that's the way we're going to do it. I just did exactly the same as BSA have done. Let me get you that diagram again. You can see there's a centre line, and then there's a 17.5 degree line for the keyway. And that's what I did. I used a protractor. No point using an amateur tractor. They're no good to anybody, and I just drew it on. So it's as accurate as I could get, just on the workbench using a protractor. but I think it'll be fine. So I'm going to go and put this in the oven now, warm him up, and then we will introduce the two lovebirds together, and hopefully we'll have a relatively easy time of it. Right, the crank has been, well, the flywheel web has been heat soaking at 200 degrees, and the spindle has been in the freezer. So I'm just going to see how easy it is to get these two to go together and get the lines matched up. I think what I'm going to do is put the tool on. And just, we are going to need a little bit of force. Our thermo advantage is going to be fairly short-lived, I think, but we are going in. That's quite nice. Not a lot of effort at all, really. One tiny little more tweak. We're down to the line. So let me just move this out of the way. We'll see how, oops, kick the bucket. We'll see how close we are. Whether we need to tweak it a bit more or go back the other way or whatever we need to do. But hopefully we've done it in one, taking advantage of our thermal difference. Yeah, I think we need a tiny smidgen more, but I'm a bit I'm a bit concerned about overdoing it. But let's see if we can just tweak it a tiny bit more. Okay. Can still just see the line, so right, let's just check it, see if we're flush. Spot on. Right, let that cool down, and we can rebuild the crank. Earlier in the video, I measured the height of the main shaft in two places, the very end and the top of the bearing surface, just to see what our original heights were. And I mentioned that I would do a comparison once we had the new shaft fitted. So that's what we're about to do. I'm expecting some difference because when we measured the two shafts side by side, there was a slight difference, the new one being slightly larger. But, you know, I don't think it's going to affect our rebuild, and I think it'll be close enough for government work, as they say. You may be wondering why we are up on V-blocks, and there's a very technical reason for that, and it's because I forgot about this step. I got all excited and fitted the crank pin to the flywheel. So we're going to zero off the V-blocks and we'll go from there. So there you go. I am but flesh, what can I say? Let's get in there and see what we've got. Okay, I'm getting 127.6
126.65, and originally we had 126.12. So yeah, we've gained a little bit there, but not a great deal. And let's have a look at the bearing surface. We're probably going to see about the same gain here. Okay, 57.94, and we had 56.10. So yeah, a little bit of a gain again, but I don't think it's going to affect what we're doing, and I'm sure we can absorb those very small gains without any problems. So pardon the pun, we will press on and get the crank back together. So what am I up to now? Well, I bought a new piece of kit, a crank balancing stand or a crank alignment stand, and that'll help me. That'll make the job so much easier, and particularly if I do any more of these cranks in the future. However, what I didn't realise was the bearings would be too small. Oops, let's move that out of the way, because I think this is a Tag Z or Tag Z, depending on where you live, motorsport stand, and I think it's designed for, you know, kind of motocross bikes and things like that, and they all have much bigger cranks these days than our spindly little 3/4 inch Bantam ones. So the crank journal just dropped straight through between the bearings. It was absolutely useless. So I bought some bigger bearings, and I've machined up, oh, don't tip the screws everywhere, I've machined up some little collars and some washers to fit them. So I've got that one fitted already. So yeah, there you go. But then I've had a conversation with Aid this morning, my good friend Aid from AG Engineering, and we both sort of came to the realization that I should have bought flanged bearings, because then I would have almost like a knife edge, because the narrower the area that the crank sits on, the more accurate you're going to be, because when you've got a fairly large surface area, you get a damping effect, and it damps out some of your error. So yeah, there we go. Now I'm hoping that I've got enough M6 screws to put all this together, because that's not something I checked, but there we go. I'm sure there'll be enough. Oh, that washer's stuck. And this is how the original ones are held on. Oh, washers all over the floor, look. It's just a countersunk screw stuffed into the bearing, which I suppose it does the job, and it's how they keep the price point reasonable, I suppose. But yeah, hopefully the way I'm doing it now will be a little bit nicer. But anyway, I'll crack on with this, and we'll get the crank in there and see what it looks like. Where's that nut gone? There it is. You don't have to do them up tight. You just have to stop the bearings from waggling around. There we go. I'll get the other two done, and we'll have a look at the crank. Okay, we're zeroed out on both clocks, and they are approximately the same distance away from the centre of the crank. So I'm just going to very carefully give it a whirl, and we'll see what we get reading wise. Got 2 thou each side. Try that again. Yeah, just about 2 thou per side. So that's in, and we're back to 0. That is in. I was hoping I could get it lower than that, but I have been chasing the error around a little bit, and I think I'm probably going to leave it at that. So the thing with this stand is you have got to be careful. You know, if you just grab a hold of the crank and start sort of wrenching on it with your hand, you will affect the readings quite a lot. And similarly, if there is a little bit of a divot in your shaft, obviously that's going to affect the reading. And there is a score in this drive side shaft, so you've got to try and avoid that. The tip of your DTI being quite wide, it tends to pick up anomalies quite easily.
But on the whole, not bad. I think I will change these for the knife edge ones though and see if it makes any difference, but not on this one. I think we're going to get this engine back together and see how it runs. We're filming on the new camera because the old one bit the dust. The tripod went over and that was the end of it. So I don't know what the quality is going to be like. We'll find out, and hopefully it's okay. But I don't think I'll film putting the engine back together. I may film bits of it, but you've seen that before in my earlier videos, so I think we'll leave it.